So here are a few sample problems that are more suitable for your level of sophistication. We're going to be adding or subtracting, so we know we will need to get a common denominator. Before we do that, though, we need to see if there are any values that will have to be excluded because they make the denominator equal 0. Sometimes we can tell just by looking at them. Often we factor first. Now for this particular problem, we won't need to factor first, because 4x minus 1 is as factored as it gets. Same for x plus 5. So we just go ahead now and we're ready to find the excluded values. What x value will make this denominator 0? So we're going to have to exclude x equals 1/4. If we put a 1/4 in for x, we'd have 1 minus 1. And we're also going to have to exclude the negative 5. X cannot equal either one of those numbers. Okay, common denominator. Something that 4x minus 1 will divide into and x plus 5 will divide into. Unfortunately for me, there is no small way to do this. Actually going to have to multiply x plus 5 times 4x minus 1. That's going to be our least common denominator. It's not like you can make both 6 and 4 divide into 12. So each one of these is going to have to get put over 4x minus 1 times x plus 5. And this one's got to be put over the same thing. Well, we got our common denominator. But how do we turn just 4x plus minus 1 into 4x minus 1 times x plus 5? Well, we just multiply by x plus 5. As long as we multiply the numerator by x plus 5, it's okay. So now we have x plus 5 times x plus 2. And we're going to have to do a similar thing here. We already have an x plus 5 in the denominator, but we also need to have a factor of 4x minus 1. So we get to multiply this by 4x minus 1 and this by 4x minus 1. Whoa. I got carried away there. Oh my. This is a wonderful first problem. And this is another one from a 9th grade workbook. So I hope you got to spend a lot of time on it in 9th grade and didn't resent it too much. We can leave the denominators in factored form, but we are going to have to multiply out the numerators so that we can combine them, combine the like terms. We're going to have to take x plus 5 times the quantity x plus 2, which you can do off at the side. You have x times x is x squared, x times 2 is 2x, 5 times x is 5x, so this is going to be a positive 7x in the middle, and then 5 times 2 on the end. And then the 7, we just distribute the 7. Splendid! Now we can combine like terms. Finally, we can add these things together. There's only a single x squared term. 7x plus 28x is a positive 35x. And 10 minus 7 is a plus 3. I don't think there's anything that will multiply out to 3 and add up to 35. Not in the factored, nice factors anyway. So that would be it. That would be our sum of those two rational expressions. Doesn't look nice, but if we did add it together, maybe number 2 will be nicer to us. Well, first we should try factoring the denominators. And we have d minus 4 isn't going to factor anymore, but d squared minus 16 will factor. So we have d plus 4 multiplied by d minus 4. And now we need to list any exclusions. Anything that will make either one of these denominators turn into a 0. Well, for this one, if d is 4. So I'll have to exclude when d is 4. And that will also take care of this one part right here, that factor. But we have to also make sure this factor doesn't turn into a 0. So d can't equal negative 4 either. Okay, so we're ready to do the least common denominator. Well, it has to be something that d minus 4 will divide into, and that d plus 4 times d minus 4 will divide into. This isn't too bad. The least common denominator is going to be this. It will definitely divide into itself, and this will divide into it. So we want both of these to be over that same common denominator. So to get this denominator to turn into this one, we're going to need to multiply by d plus 4, which means we have to multiply the numerator by d plus 4. So this numerator now is going to turn into 3d plus 12. And we're going to subtract the d and the negative 9. And lots of people go through all this wonderful stuff getting the denominators, and then when it comes to the subtraction, things go wrong. So this is all still over d plus 4 times d minus 4. We have 3d plus 12 minus both of these, minus the d and minus the negative 9. So that ends up becoming a positive 9 when we subtract. We're getting there. We have 3d subtract a d and 12 plus 9. That's that. The numerator doesn't even factor. So this isn't one of those that we're going to get to reduce or anything. It's just going to sit there and stare at us. But we did subtract. We did accomplish the subtraction, which was our goal. This kind of answer shows up in calculus pretty often. And it's not hard, just a little weird looking to start with. Right now, this one doesn't have a denominator. We can make it have a denominator. If we make this 3x over x plus 2 minus 2 over 1, you can make any integer look like a fraction by just putting it over 1. So checking out our denominators now. Any exclusions? Well, not much, just one value. We're going to exclude when x equals negative 2. Okay. Common denominator. Well, it's got to be something that x plus 2 divides into and something that 1 divides into. So it's looking like it's going to be x plus 2. We need each of these to be over x plus 2. Well, the first one already is. To get the second one over x plus 2, we're going to have to multiply by x plus 2 down here in the denominator, which means we'll have to multiply by x plus 2 up here in the numerator as well. But you knew that. So this is going to be minus, wrong pen, 2 times x and 2 times 2 . And I did make that a big negative sign on purpose, because I want to emphasize that we're subtracting both parts. So we have 3x, subtract the 2x, subtract the 4. And I know a lot of you do not need this step. You can just look at it and come up with the answer. I want to emphasize that we had to subtract both of them. So it's looking like 3x minus 2x is x minus 4. Please be careful. It's so tempting to want to cancel the 2 and the 4. We cannot cancel those because you can only cancel if you have a factor being multiplied. You can't cancel if there's a plus sign or if there's a negative sign. So these are kind of messy, but they are going to be possible. And I'm going to ask you to please stop now. And there are 2 try your own problems to work on. And we'll come back in a moment when you're ready and check the answers out to the try your own.